What is a piecewise function, since you guys all remember them so well?
There's like a function.
Grass.
Three
Functions put together, but with inequalities of where they can and can't be.
Okay. So piecewise means it's defined differently on different parts of the domain.
This is really like Algebra 2 Part 2.
So we don't just have a single, square or absolute value or x cubed or anything like that. We have different rules depending on what the x values are. When we talk about piecewise functions, we will mostly be graphing them and answering questions from the graph. When we graph them, our strategy is really going to be to use a t-chart to get that. So yes, we do know the parent functions and transformations, but a t-chart can help us a little bit with trying to decide where the graph is and isn't. So that's the strategy I am going to use when we go through these. So let's take a look at one, and we're going to draw a graph. Okay, so my first one.
Looks horrible already.
All right, f of x equals 2x plus 4 if x is less than 1, and 4 minus x if x is greater than 3.
Oh, I remember this. Yeah, I don't like these.
He wasn't even in our class last year. He was in a different hour.
He wasn't in.
So was she. So was she. So was mine.
I didn't take out.
All right, we can do this, guys.
No, we can't.
So here's what we're going to do. All right, let's start with the first piece.
My computer.
Nope.
We are going to make a t-chart.
Yeah.
Whatever this x is, we have to plug in. Put the calculator down. We don't need that. Put it away. We are going to put in 1 first. Now you'll notice the 1, it just says less than. It doesn't have an equal to. So how would I show that on my?
Open circle.
It will be an open circle at 1 because it did not have an equal to. And then it says the x's have to be less than 1. So give me a couple values that are less than 1.
-1.
0, -1. Okay, let's graph this. So if I put in a 1, 2 times 1 plus 4 is 6.
Yeah.
If we put in a 0, we get 4. If we put in -1,
2.
2.
I mean, 2. What?
This dude.
Piecewise, man.
I was calling Pennywise.
What?
Okay, so on my graph, I'm going to put an open circle at 1, 6. Then we have a circle at 0, 4, and -1, 2. The open circle is my starting point, and we are continuing on this for everything less than 1. So I started here,
Oh, these aren't that good.
and I go this direction, and it would just keep going because I don't have a stopping point. I just said for everything less than 1. So that's my graph. I have a starting point. It's extending to the left. That's the first piece there. Is everybody okay with how I got that one?
Yep. What was that laugh?
So now let's do the second one. We always have to put in the starting point. So I have to put in 1. Would this one be open or closed?
Close.
Closed, because it has an equal to. And then we need things greater than that. So maybe a
1, 2, 3.
2 and 3.
1, 2, 3.
So then we plug them in to 4 minus x. So 4 minus 1.
3, 2, 1. Oh.
2 and 1.
Okay. So 1, 3 is a closed circle. 2, 2, 3, 1. So it started here, and we were going for everything greater than 1, so it extends this direction.
No, they can work that.
That wasn't so painful.
Yeah.
You need to do a
My
quick,
calculator went right.
kind of, a little extra. We need to do a quick check at the end. These are functions. I said f of x, so it's a function. If you're looking at the graph of a function, it has to pass the vertical line test. So this one does. If I had like 2 closed circles here, or I drew one of my lines the wrong direction, it would fail the vertical line test. And that's your big red flag that you've made a mistake and we need to go back and look at it. Okay?
I think Miss Keller ruined graphing for me when she yelled at me because my parabola was too pointy. Too pointy.
Alright, is this one okay with everybody?
Too hard.
We can do it.
So is it possible for a function to be like no solution because it's
And it wouldn't be a
If
function.
I graphed it, like let's say
There's the-
this first piece also had an equal to 1. So let's say that. So then there would be 2 different closed circles there.
It wouldn't be a function.
That would not be a function.
Do we do that now, function?
Yeah.
This is good.
So it has to pass the vertical line test. All right. Let's try some more, because I think we need the practice. Bless you. Alright. So if I'm graphing the first piece, we have to decide what kinds of values we can plug in.
0, 1, 3.
We have to start with 0. Now then it says x is
Less than.
less
-1, -2.
than.
Oh, snap.
Would the 0 be open or closed?
Close.
Closed, because it had an equal to. So if I put in a 0,
-2.
opposite of 0 is 0, minus 2 is -2. If I put in -1, opposite of -1 is +1, minus 2. If I put in a -2, opposite of -2 is 2, minus 2
0.
is 0. So I have a circle at 0, -2.
Now I have all of this. Now I have lunch.
Make sure you're only extending your line one direction, so we started here, and we're going for everything less than 0. So it extends like that.
Yeah, it's nighttime, it's national.
Right. What do I have to put in first?
0.
Yeah.
But what do you know about that 0?
It's open.
It's open.
Okay. And then I need things greater than 0.
1 and 2.
So if I put in 0, 1/2 times 0 is 0, minus 2. 1/2 times 1 is a half, minus 2.
Negative 1.5.
How do we show if it's open? It's our point.
That's
Like
open.
that big
Oh,
circle.
I'll show you in just a second. If I put in a 2, 1/2 times 2 is 1, minus 2 is negative 1. Okay, so I said an open circle at 0, -2, and I already have a closed circle there. If it's already closed, you just leave it closed. You don't need to draw an open around it or anything, we just leave it closed. We're right here. Then we have 1, -1.5, and 2, -1.
Hey. That's good.
It's like absolute
Kind of
value.
like a little absolute value.
This helps a lot.
Except it doesn't show you which half of the things you want.
That's the part you gotta know.
Okay. Let's do some more. So, here is my function. I'll give you a second to write that.
That's what gets me. -3 is less than or equal to x.
Yes, you are. Alright. So you have me at first?
You lost me.
Just write down your function.
Alright. I trust
I remember the last time you did, you said one more, and then we did that one more.
There
and
was
then
one
you
more
put-
slide.
And then you put another one up there.
There was one more slide.
And then you just kept going, and then I got looked at my
Nothing.
Okay,
Gaslighting us.
so I'm asking a few different questions on this. The first question I'm asking you, I want to find f of 0, f of 1, and f of 2. This is really just checking if you know which piece you're on. So if I said f of 0, if x is 0, look at your requirements. Is 0 between -3 and 1, equal to 1, or greater than 1? It's between. Does everybody agree with that statement? If I said x is 0, we're here.
Yep.
So if I want f of 0, you plug 0 into this piece. So the opposite of 0 plus 1 is 1. So f of 0 just equals 1. It's a function. You can only get one answer out, so we can't plug it into every single piece. So this first one, I'm just checking, do you know which piece to plug it into? So if I said f of 1, if x equals 1, which piece are we on?
2.
2.
And this says we just get out of 2. If x is 2, which piece am I on?
Last one.
The third one.
The third one. So, because 2 is greater than 1, so 2 squared is 4. All right, so I might just ask you to evaluate. Tell me what those things are equal to. We'll do another example of that in a second, just to make sure you can handle that. The rest of these questions, I'm going to graph it first and then give the domain and range from the graph, okay? So when we graph it, we do one piece at a time. Let's talk about the first piece.
I agree.
How is that piece different than the other one?
It's an and.
Okay, I gave you a starting and a stopping point. You have to plug in both of those. So I have to plug in -3, I have to plug in 1, and then I could do something between them.
0.
All right. Are these open or closed at -3 and 1?
Closed at 3, open at 1.
And everybody understands why it's open at 1?
Yep.
So then we plug them in to the -x plus 1. So the opposite of -3 is 3, plus 1 is 4. Opposite of 0 is 0, plus 1 is 1. Opposite of 1 is -1, plus 1 is 0. So -3, 4 was a closed circle. 0, 1 is closed, but 1, 0 is open. Because this had 2 endpoints, we're not extending either direction. It just starts and stops. It's just a line segment, only between those points. The next piece. 2 when x equals 1. So what is the only thing you can put into this one?
2. Or 1.
The only x value we can use is 1, and we get out a
2.
2. This is just a point on the graph. 1, 2 is just a single point. The last piece. X squared if x is greater than 1. So what do I have to plug in?
1 open.
A 1, and it would be open. And then we need things greater than 1, so maybe a 2 and a 3. 1 squared is 1, 2 squared is 4, 3 squared is 9. So 1, 1 is an open circle, 2, 4, 3, 9. So we're getting part of a parabola here. Does this one just stop when I get to 9? No, because it was for everything greater than 1, so it's just going to keep going on that end only. All right, so domain. As I go from left to right, what's the first value we hit?
-3.
It's a bracket because we actually hit it. Okay, this piece stops at 1. Do I have anything that actually hits the 1 though?
Point.
That orange dot does. And then this keeps going forever, so it'd be -3 to infinity. The range. What is my lowest value?
No. It's open.
It's an open, so it'd be a parenthesis at 0. And then do I hit everything above that?
Yep.
Yes, so 0 to infinity. Is this graph continuous?
No.
No, we have a break in the graph. Questions there?
Are we done yet? That's my question.
Let's do, let's graph this one.
There's gonna be a method, so.
No, she's giving us a handout. No.
Ow. Come on, yeah, don't do it.
Correlate.
How many T-charts do we need to graph this one?
Wait.
2.
We have 3 pieces, so we need 3 T-charts.
No, we don't. Not for the second
Why don't
Yes,
you
you
wait
do.
a second?
Stop arguing.
one. Okay.
I'll show you what I
I
mean.
digress.
Dude is the teacher apparently.
Y equals 3, but it's something between 2.
Yeah, you
Oh.
have multiple, so it's not just a single point. Okay, so for the first piece, what do we have to plug in first?
2.
We have to do a 2. Would it be open or closed?
Close.
And then we want things less than 2.
1, 0.
Alright, so if you put in 2,
3.
2 plus 1 is 3, 1 plus 1.
3, 2, 1.
So 2, 3 is a closed circle. 1, 2, 0, 1. So it starts here. We didn't have a stopping point, so it's just going to keep continuing. The middle piece. What do we need to do on this one?
Plug in 2 and 4.
Right, we have a starting and a stopping point. So we have to do 2 and 4 and something in between, so 3. At 2, it would be,
Open.
and at 4,
Closed.
okay. And what am I getting out every single time?
3.
A line. No.
With
No.
3.
We get out the number 3 every time. So 2, 3, I said open, but I already have a closed circle there, so you just leave it closed. 3, 3, 4, 3. So this one, we have a starting and a stopping, so it doesn't extend either direction. It's just a line segment, just a horizontal line.
So.
Well, so is this one.
Goofy.
What about this one? First number has to be
4, 5, 6.
4, and then we need things greater than that. At 4, is it going to be open or closed?
Open.
So if we put in 4, negative 2 times 4 is
Negative
negative
1.
8, plus 7 is negative 1.
2.
Negative 10 plus 7 is negative 3.
Dang. What about that?
And then 6, negative 12 plus 7 is negative 5. So 4, negative 1 is open. 5, negative 3, 6, negative 5. This doesn't have a stopping point because it's for everything greater than 4. So this arrow just continues. What is the domain of this one?
Order.
And infinity positive.
Order. Yeah.
Because it does keep extending both directions. What would my range be?
3 or negative
Oh,
3.
it's, I don't know.
Negative infinity 3 because we don't hit anything above.
Oh, I didn't see that. I didn't compute that one.
Questions on this one?
Nope.
Yes, sir.
Do you want us to do the teachers?
Yes.
I need to be able to tell where your points are exactly. So
So
I
yes.
strongly recommend it. If you are extremely confident, then as long as they are marked clearly on your graph, that is okay.
How do you do that with that teacher?
Here, just make sure you
You're
have,
just not writing it down. You're still really plugging in the points.
just
and
make sure
doing
you
the
have my
teacher.
graph calculator.
Mm.
Yep.
Realize.
It has all the tables you need today.
Last problem I want to do together.
That's 4 parts. Not here.
4 million.
We're not actually graphing this one.
Oh, I just started drawing a graph.
I'm just asking you to evaluate some things.
Man,
So this is just a matter of recognizing, first of all, it's a function, so anytime I plug in a number, I can only get one answer. So I have to know which piece to plug into for each of those. Okay, so if x is 0, to decide which piece, I'm looking here. So I have to ask myself, is 0 greater than -2, equal to -2, or less than -2?
Greater.
Greater than -2. So we plug it into the first piece. So 2 times 0 minus 1 gives me -1.
that's bogus.
What's wrong?
Negative 2.1.
Which piece would you plug it
Last
into?
one.
Less
The
than.
last one.
It is less than -2. So you have 6 minus 3 times -2.1.
6.3.
You get 12.3. -2, which piece do you plug that one into?
Middle one.
Middle one, so that's x squared, so -2 squared,
4.
positive 4. And 3, which piece do we put it into?
The first
Oh.
one.
So 2 times 3 minus 1. And we get 5. So I might just ask you to evaluate, which is a pretty simple calculation. You just have to decide which one to plug it into.
Put a box around your floor. Thank you.
You're welcome.
How do you want us, like, signifying which one? It's just putting it in, like, showing.
Yeah,
the
you're just showing your